Hey, this is Gary, and welcome back to my channel on making a 2D framework using LibGdx. This video, I'm going to go into making a simple shoot 'em up type of game. First thing I want to do is update my LibGdx version. So currently I was on 1.10.0, so 1.12.1 is out, so I've updated that. As far as the framework goes, the only thing that I had to change was related to my mock input that I use for testing. So the cancel vibrate is no longer a method on the abstract input, and vibrate is no longer a method. So there is a new vibrate method that takes an int and a boolean, and one that takes two ints and then a boolean, and then one that takes a vibration type. So that was what changed within the framework. Now in our video tutorial side of that, so I need to upgrade here, GDX version to 12.1. And then also with that update, we need to update this Bad Logic Games, the GDX backend LWGGL to 3. So per the documentation, LibGdx 1.11.0 went to updated to version LWJGL3. So this requires us to upgrade from LWJGL to LWJGL3. And so that changes the configuration for our desktop launcher. That's the biggest change here. And so our desktop launcher, you'll see now the LWJGL application configuration is no longer a valid class path. So that has changed to LWG3 application configuration. And also requires this to be changed to LW3 application. And also the way of setting the height and width has changed. So now you go to configure, you want to set the window mode with your width and your height. And also in the config, you can set the title. So it's a video tutorial. And I'll run that. And this is the tutorial from last episode. And now you see our name is now video tutorial. And one of the other things, just as a note, that you could set is you can set the window icon. So you can set a file type and a file name. I won't go into that in this video, but we can go into that later. So that's what's involved in upgrading to the latest version of LibGdx at the time of this recording. Okay, now we're going to get into making a simple shoot 'em up type game. So we're going to go over kind of the basics, right? So I'll make a little square here. So this would be essentially our ship. And the ship will move in basically in this area, go back and forth between the two ends of the screen. And what I'll do is I'll have elements that will fall down and you could shoot. And then as the game progresses, enemy ships will come in and then they will be able to move around in this area, maybe come up and down, and then shoot at your ship. So that's the basics of what we're going to do. Okay, so the first thing we're going to do is I'm going to make a base screen. So shoot 'em up screen. We're just going to use the simple screen. Have our show method. So the graphics on a video game can be difficult or easy depending on your artistic abilities. For this, so I'm just going to kind of do it simple. We're going to use a block animation. This will be our ship animation. And we're going to make our ship, he's going to be 100 by 40. And we're just going to have a single motion. That'll take our ship animation. And then I'm going to create a new class for our ship. And the ship will extend the actor. And then we need to generate a constructor. And it will need to take a motion. Now the super takes a movement, move motion, and a still motion. And for this, we're just going to use a 2-key movement. Input keys dot right, input dot keys dot left. And speed, we're going to use a float of 4. And it's going to be a horizontal movement. And we'll pass in our motion for both the still and the moving. So back in our screen, create our ship. pass in our ship motion. And for our ship, we're going to set is location. So we're going to put him right in the middle. So that'll be the width. Divide that by 2 minus half our sprite's width, which is 100. So that's 50. And we're going to make them 60 pixels from the bottom. And then we'll just add our actor. It's our ship. So in our desktop launcher, we're going to change the screen size. We're only going to be 700 wide, but we're going to be 900 up and down. And then here, we need to use our new shoot 'em up screen. And then we'll run that. All right, and here is our ship representation. And we can move them side to side. You notice it goes off of the screen. So we need to make a correction for that. Back into our ship object. We're going to override the update method. If our x is less than 0, then we'll just set our x equal to 0. Then we do an else if our x plus our width is greater than gdx dot graphics dot get width. Our x is going to equal that gdx graphics get width minus the sprite's width. Now you see that he stops at each end. So if I wanted him to kind of not hit the end, I can adjust that so that he stops sooner. So for example, if I wanted him to only go up to 10 pixels away, or maybe let's do 5. So if he's like 5, go no further than 5, the width plus 5 plus 5. Actually, that'd be minus 5. Stops just short of the edge on both ends. So the next thing we'll want to add is our laser. We just get the input, key just pressed, do our keys dot, and we'll just use the space key. That'll be firing. And so it's going to be firing our laser sound. So we need to add a sound to our ship. And we'll need to pass that in. So when the space key gets pressed, we just do laser sound dot play. So now in our constructor, I just need to add that. I'll get sound. And so I have a laser file. So I've created this laser sound, and I use the chip tone that I demonstrated in a previous video, and we'll play it for you. It's just a simple laser sound. So we'll add that. There's our game. So you can shoot. Next, we're going to add the actual laser. It's going to be an actor because it moves. Now, the laser is going to have to generate a bunch of those because as you shoot, more and more get displayed onto the screen. And to do that, we're going to create an actor factory. And what it does, it contains the base screen so that it can add these actors onto the screen. We also contain a queue so that we can add up a bunch of actors ahead of time and not have to constantly create them every time that one needs to be added to the screen. The default queue size is 5, so that they'll create 5 of these actors, put it into the queue, and then as they're needed, they're pulled out of the queue. So I'll show you that in a moment. So this is our base constructor, and there's also a constructor to set the queue size. Here is the kind of the main method to create a new actor, and you pass in the X and Y coordinates. And so it checks to see if the queue is empty. So if it's empty, it will construct a new one. Otherwise, it'll pull the first element off of the queue, call its reset method. Then it sets that actor's location, and then calls the base screen add the actor. This is our method to set up the queue. You'll want to call this inside your constructor of the class that you extend this with, and that will build the actors and add them to the queue based off of your queue size. So the sprite remove method is for when an actor is removed from the screen. You will want that actor to call this method, passing itself in, and so that it can be added back to the queue for being reused. And then we have some abstract methods, one for building the movement, one for building our move motion array, and one for building the still motion array. And then we have the construct method, taking those build movements and build motions. In the actor class, so I've added a reset method. And so what it does, it will set the remove back to false and then call the movements reset method. So if you need to update any type of other changes in your child classes of actor, you would do that in this method so that it could be in a kind of that pristine state when it's like first constructed. Then in the movement interface, I've added the reset method there. The default operation of reset does nothing, but in the script movement method, it sets the current action back to that wait action, sets the done back to false, and resets the current index to -1. So now it's ready to go through those motions again. And another update that I did was add a list of updatables. So we have an interface for updatables, which has a single method called update that takes that delta time. And so what this is as far as for any type of operation that you want to do, or as the game progresses, but they don't display anything directly to the screen, you will implement that updatable interface, and then you can add it to your screen. Another update I did in the simple screen. So since our sprites are in a list and we are iterating through them, we want to avoid concurrent modifications. So we add elements to that sprite list. We don't want to do that while we're in this loop of iterating through and updating and displaying each of the sprites. When we add a sprite, check to see if the render cycle is on, and you can see that we start the render cycle here and we turn it off here. And if it's on, we add it to this other list to be added. Otherwise, if the render cycle is off, we can just add it to the sprite list directly. And so what it does is it checks to see if our to be added is not empty. Then we just add everything and we clear out our to be added. So it's pretty simple. So now we're going to go back to our game, and we're going to start by creating our laser class. We'll just call it laser, and that's going to extend our actor. I want to add this constructor because that's the one that our actor factory will use. So I'm going to add some constants for our size of our laser, and then we'll need to override our update method. We'll call the super update method. But then we need to check to say, hey, if our y is greater than the height of the screen, then we want to set the remove to true. Now, the next thing we need to do is create our laser factory, and that'll extend our actor factory. And this will need to be a laser, so that's our type. Now we need to create a motion array for our laser motion. Create our constructor. That's going to have to take our base screen, and we're going to pass in the animation. So our laser motion is going to equal a new motion of one element, and that motion is going to be a new single motion that takes our animation that we pass in. And then once that is all set up, we're going to call the setup queue. Now we overridden our abstract methods, so we need to implement those. Here we're going to return a new single movement. We're going to have a speed of 4. The direction is just going to be north. Then we're going to override the handle collision method, which will just be the sprite update dot set the remove to true. So whatever he collides in will be removed. We'll update this when we get to adding the enemy ship. Now on our build move motion, this is going to return our laser motion. And then our build still motion, it's also going to return our laser motion. In our construct method, we're going to return our new laser. Now we need to update our laser to have our laser factory. We need to add that to our constructor. Let's finish out our laser factory first. That's going to return a new laser. I'm going to call build build movement method, our build move motion method, our build still motion, and then we're passing in this laser factory. So that's our laser factory. And then we'll want to call the constructor to set our queue size higher than 5. So let's do 15 for right now. We go back into our ship class, and here we're going to add that laser factory. And then we're going to add that to our constructor. And then we'll set that. Now here in our fire method, we're going to call our laser factory. We're going to call create new actor. And we're going to take the x coordinates of the ship. We're going to take its width, divide that by 2, which will put that at the center. And then the y, we're going to add the laser height to that, plus the height of the ship, so that it will start out right in front of the ship. Now back into our shoot 'em up screen, we need to create our laser animation. Now since we're making this really simple, we're just going to do a block animation for the laser, and we just call laser dot width, and then laser dot height, and we'll set that color. We'll just set it to red, and then we're going to create our laser factory. We'll pass in our base screen and our animation laser, and then in our ship, we're going to add the laser factory. Now we'll test that out. You see we can shoot multiple lasers. So I realized that we only had about 7 lasers on the screen at one time, so I'm going to bump this down to 10. So the next thing we're going to do is create our obstacles, which will fall from the top and basically try to hit our ship. Create an obstacle class. We'll extend our actor. So we're going to use the constructor that takes the multiple motion arrays, and that's because we're going to use a actor factory to populate the screen with the obstacles. First thing we need to do is we're going to have a boolean to keep track of whether or not it's been destroyed. And that gets set to false by default. And what we're going to need to do with that is we're going to override the contains method, and if it is destroyed, we're going to return false. So essentially it will never collide with anything after it's destroyed. And next we'll need an obstacle factory. So we'll create that. We'll extend our actor factory. Type will be obstacle. We'll implement our abstract methods, add our constructor, and then one thing we'll need is a static motion array, because the motions are no different between any of the obstacles on the screen. They're all essentially the same. We're going to need to keep track of the current time so that we know when to display another obstacle. And we'll need a random object. And we're just going to use the Java's random. Then in our constructor, what I'm going to do is pass in a random object, and then we'll just kind of reuse this random object anywhere that we need it. Set that random, and then we're going to have our move motion, call it motion move, be just a block animation at this point, and we'll make it 20 by 20, and we're going to color that. We'll make it brown. Another motion to be our motion destroyed. Do another single motion and another block animation. And that'll be 20 by 20. Motion destroy. We're going to set the color. Set that color to red. Then our motion array. Have 2 elements. 1, 0 is going to equal our motion move. And our motion 1 equal our motion destroyed. Set up our queue. And we're going to start about 15 of these objects. Build movement. We're going to use a move action, and the move action will go in a single direction and not stop. This direction will be south. We're going to do a speed of 4. Do a script movement. We're going to pass in our action. And then we're going to use our easing action. So this is the action once it's destroyed. It'll ease out. And we're going to do speed of 2 and direction. to be south, and we'll just do a by using power movement. We're going to add our action, add our action 2, and then we'll return our movement. And here we're just going to return our motion array we created in our constructor, and the still motion will return the same thing. And then in our construct method, we're going to return a new obstacle, do our build movement, build move motion, or build still motion. One thing we need to do to get our obstacles to appear on the screen, we need to implement the updatable. This is our update method. And what we're going to do is we're going to add the delta time to the current time. And if our current time is greater than 1 second, we're going to create an obstacle. We're going to use our random. We're going to get the next int and our bound tx.graphics.getWidth. Then for the y coordinate, GDX graphics.getHeight plus 20, which is the size of our box. And to make things simple, we'll set the current time back to 0. And then every second one will be put onto the screen. Now back into our obstacle to add the obstacle factory so that we can tell it when we're done. Our factory, add that to our constructor. Then we need to override our handle collision. And then we just do an update, check our current move motion is equal to 0. That's a script movement, and we're going to call the next action. So that'll go into the ease out. Now we'll set our current move motion index to 1, and we'll set our destroy flag to true. So now it won't collide to anything. And now we need to update the update method, call our super update, and then if our y minus the height is less than 0, which means we fell off the screen, set our remove flag to true, call our factory sprite removed, pass this in, and if it is destroyed and our script movement is done, we will also call factory.sprite remove, pass this in. And then back in our obstacle factory, we just need to pass the obstacle factory in. All right, then we'll go back to our shoot 'em up screen. And here we're going to add the random. Then in our show method, and we'll create our random object here, get the current time, and then we'll create our obstacle factory. Pass in their screen, and then we're going to call the add updatable, pass it in the obstacle factory. All right, let's test this out. I noticed we have some problems. One is that when it stops, it's not removing them right away. So let's get that fixed. Okay, first to fix the obstacle, what we need to do, actually, our handle collision, we can just do if not destroyed. And we need to add or override the reset method. Okay, in the reset method, we're going to call the parent. We're going to set the current move motion to 0 and set our destroy to false. And another thing we need to do is once the destroyed and the script movement is done, we need to set remove to set that to true. And what I'm going to do is add a isDestroy method here so that we have access to that. Now in Laser Factory, we actually don't have to handle the collision as part of this single movement. So we're going to get rid of that. And then in the ship, we need to add the handle collision. And what we're doing here in handle the collision, if the obstacle is what we're colliding with and it's marked as destroyed, we're just returning. So we're not going to handle that. And then we just call the super. One other thing that I'm going to do is in our obstacle, we're going to slow down our obstacles a little bit so they're not quite so fast. And we'll also slow down the ship a little bit. All right, let's give that a test. There we go. They're coming down the road much slower now. I'm going to hit one near the top. There you go. You can see they're slowing down and moving off the screen. Alrighty, that's got it working. So one thing we also need to do is when the laser gets hit, laser needs to be removed from the screen. So we'll implement the handle collision method. So we'll set the remove to true if it's an obstacle. And we also need to check if the obstacle is not destroyed, then we remove it. That's going to do it for this video. Next time we're going to go into adding the ship and do some other modifications to our game and kind of get a first draft of that up and working. So if you have any comments or suggestions, just list them out below and feel free to subscribe, and I'll see you in the next video.